This I'm making this recording so that my stat teacher volunteers have something to base how they can run the class on. So I'm just figured the easiest way would be for just me just kind of show you how I would do this problem or run the class. You probably already know because you see me run the class, but might be helpful. Okay, you don't have to do it exactly like I'm doing it. You do it like your style, okay? But this is kind of how I would do it. I'm wearing my mask because you'll be wearing a mask, so it does kind of limit the ability to express things. So I just figured that would make it a little bit more realistic. And I hope you can see me well enough in the little upper corner. It's a little bit backlit. Now let me actually see if one thing might fix this a little bit. Pause. Now what I tried made it worse. So so we'll just go for it here. I hope you can see me well enough. And I will be writing on the board. See me in the little corner. Okay, so here we go. I generally like to start by reading the question. A statistics professor conducted a study in which he taught two sections of the same introductory class with one difference between the sections. So right there, I'm going to highlight a couple of things. And this is just kind of going along, trying to think about what might be important. I would say, oh, well, there's two sections that might become important. And one difference is telling me, that might be a variable because it's something that kind of that differs. But I'm not sure. I'm just kind of reading the question through. In one section, he used only examples taken from sports applications. And in the other section, he used examples taken from a variety of application areas. The sports themed section was advertised as such. Okay, so we know that people knew what they were getting into. So students knew which type of section they were enrolling in. The sports themed section was also scheduled earlier in the day than the regular section. At the end of the semester, the professor compared student performance in the two sections using course grades and total points earned in the course. So if I'm looking at this, I'm trying to say, well, what is this guy trying to do? Well, I think what he's trying to do is he's trying to figure out, well, I might ask the class for some comments. What is the professor trying to do? And wait a minute and let people answer. I will set up the magic bowl. If you want to use the magic bowl, it'll be there for you. I'll show you how to use that. But that's a good, what is he trying to show? And I think what he's trying to show here is that maybe there is a difference in scores between a sports section and a regular section. So we identify the observational units in the study, and we have to identify three variables mentioned in the preceding paragraph. Okay, so I'm looking at this and I'm thinking, well, I think this one's a little bit difficult to determine what are the observational units, because I mean, my gut reaction is that the observational units are the students. But I'm going to identify the variables first, and that's what I would encourage you to ask the class to do. What are the variables here? And then we can see what are the variables describing, and those are the observational units. So let's just think this through here for a second. So I'll be totally honest with you. I just had to pause the recording there for a second because I wasn't really sure. So I had to think it through a little bit. So I am going to start with the variables, and I would probably write these on the board. I think you can see the board over here. You have two boards that you can work with. So one variable I can see is are you a sports section or regular section? And I think that's a categorical binary variable. And then You know, you might look at it and say earlier in the day and later in the day is also a variable, but I don't think that's a variable because the sports section is earlier and the regular section is later. So those are characteristics of the section, but they don't really vary from section to section. You know, if you say sports section, that's going to be the same thing as earlier section. If you say regular section, that's going to be the same thing as saying later in the day. So the other variables are the grades, and the points earned. Now, here at NDA, we might consider grades and point earned to be the same kind of a thing, but really they're different. You know, you can earn grades earned is a categorical variable. That's AB's categorical. That's A, B, C, D, F. Points earned is a quantitative variable. So if I'm looking at this, I'm saying, well, what section, what's the grade, what are the points? Then I actually do think that the observational unit are the students. Because what section they're in describes a student. What grade they get describes a student. What points they earned describes a student. So the individual students are, in fact, the observational units. I hope that's clear. Think about it. If you have any questions, let me know, and we can go over it to make sure you understand it. So now I'm going to go to the next slide. Right. So actually, we have dot plots. So the dot plots compare the distribution. Let me see if I can move this little thing out of the way here. That's better. Of total points earned in the course out of 400 possible points between the two sections. So yes, we can see that each dot is an observational unit. That's how much they earned in the course. That's how many points each person earned in the course. So compare and contrast the point distributions between the two sections. Comment on both tendency and consistency. So, you know, give the class a few minutes to think about it and then go to the magic bowl and take some answers. So if I'm looking at this, what are some of the things that I am seeing? Well, the highest score is in the sports section. I would say, though, that the regular section tended to have higher scores. They don't have a whole bunch of these low scores over here. Their center is probably at a higher number. And if I was to estimate it just by ballparking here, I would say their center is like right around here. Whereas for the sports, I would say their center is just a little bit lower, not much lower, but definitely lower. But the other thing that's very clear here is that the regular section has more consistency than the sports section. It has less spread. It's not as spread out. The sports section is more spread out. So when I say that one section tended to score more points than the other, yes, I think it's pretty clear that the regular section scored more points than the sports section. And it says justify your answer. I don't know that I would necessarily do that in class, but if I was doing that on my own, I would probably look for the median score. And if you want to do that in class, that's okay. Median is the middle value. If you don't want to do this part, you don't have to. But median is, if you're comfortable with median, it might be a nice thing to explain. We'll learn about it in a future lesson in greater detail. But again, if you just want to kind of put it in their heads, that's okay. So median is the middle value. So if I look at how many do I have in the regular class, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29. So about almost through 29, that would be, middle would be 14 and a half. So like right between 14 and 15. So starting at the lowest end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my median is going to be right there at 340. For the sports, how many students do I have in that class? Because it might be different numbers of students in each class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 28. So I have one less. So I'm going to look for where score right between 14 and 15 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right in here is going to be the median for the sports. So clearly the tendency is higher in the regular class than the sports class. Moving over to here, I'm probably out of revision, but I'll get into it again. Did every student in one section score more points than every student in the other section? If not, explain what a statistical tendency means in this context. So basically what there's, I mean, it's clear that every student didn't score higher in one section than the other. I mean, even though the sports section has a median that's a little bit lower, the regular section is higher, but we have, well, the highest score was in the sports section. So actually everybody in the regular section scored lower than in the sports section. So tendency means like on average. And that would be a good thing to say a few times because, well, yeah, tendency means on average. And even though I said that several times and you'll say it several times, in teaching, it's good to repeat things several times because different people hear it at different times and in different contexts. So that's what a statistical tendency means in this context. It means kind of on average. So that we want to get the relationship between tendency and on average. So the next slide, we have the same dot plot there. Suppose you categorize this is interesting. Suppose you categorize student performance as good for students earning at least 85% of the possible points, fair for students earning at least 70%, but less than 85%, and poor for students earning less than 70%. Now, this is turning the points, which is quantitative, into a categorical variable. It's going to be, what is it? Good, fair, and poor. So grades are categorical, but we're not using A, B, C, D, F. We're using good, fair, and poor. I'm not sure if you can see that on the screen, but I'm writing it. Yeah, I think you can probably see it a little bit. Good, fair, and poor are categories for grades instead of A, B, C, D, F. So they're telling us here, the regular section had 16 good, 11 fair, and 2 poor. The sports section had 7 good, 15 fair, and 6 poor. So for each section, categorize the proportion of students falling into each of 3 performance categories. So I have to make a note here to show you how to call it the TI calculator. Okay, so I think you can, well, I don't know if you can see me or not, but I'm pushing the start button. And over here is TI Smart View 84 Plus, and it'll take a second and it'll come up. And once it comes up, what you want to do is you want to press the View menu and then always in front. And that keeps it there, because if you don't do that, then when you kind of go back to the board here, you kind of lose, it vanishes. So when you want to make the calculator go away, you just press the little minus key and it goes down to the bottom, and then you tap it again and it comes back up. Or if you don't really want to do it on that, you can just have your calculator in your hand and tell other people to get their calculators out. Can you see me? Oh, if you don't want to do that, you can just put the calculator in your hand and tell all of the students to get their calculators out and just do it together. It's not such a big deal. But so I want to know the proportion of students falling into each of the 3 performance categories. So, and again, here I would ask the students, like for the regular section, it's 16 good. What is the proportion in the regular section? Well, give people a chance to answer. You could do the magic roll if you want. You might want to take volunteers. It's entirely up to you. We have 16 out of 29 total. So 16 divided by 29. Well, then my proportion, sorry, you can't see me, 1/6 divided by 2/9. My proportion, I would probably round up to 2 decimals, is 0.55. And then I would do the same thing. I would have the students do the same thing for each one of these. You don't necessarily have to do it together, but you've shown them how to do it once. To have them repeat it a couple of times and do it on their own, they'll get the proportions. And then I would just write down the proportions that they give you, or you can say, this row do, well, no, easiest that way. So get the proportions that way. So we calculated the proportions, we did F. And then in G says, construct bar graphs. So bar graphs are for categorical variables of the performance categories for each section. So the variable that we're looking at is the performance categories. No, I take that back. The variable we're looking at here is each section. So this is a little tricky. I paused so that I could kind of think it through a little bit. This is a little tricky. So I would let the students work on this because we're going to probably get 2 different kinds of answers. And maybe the way to do it is to write the 2 different types of charts after people have a chance to work on it on the board. So I'm going to put it here on a new page. To get a new page, push this little green plus arrow down here in the lower corner or up here at the top. And so I'm pushing the arrow, and I got a blank page. Now, what I wrote down on the sideboard over here is I made a little table of good, fair, and poor, and then I had the sports class, and I had the regular class. So I have a little table here, and my numbers are wrong spot. Sports is a 0.25, 0.54, 0.21, and regular is a 0.55, 0.38, and 0.07. So one way to do the graph is to say, I'm thinking how to do this. So one way to do this, or one way that you'll see students do this, I think. Can you see me? Off to the side, maybe let me just angle it just a little bit more. That's a little better. Okay. Is here's my graph. And here's 100 or 1.0, and here's 0.5 is proportion. This is my y-axis. And Some students are going to put good, fair, and poor on the x-axis. And this is not what we're going to want, but I'm going to show you what it's going to look like anyway. So if I look at the good, the sports had 0.25, so right about to here. And the regular had 0.55, so that would be like up to there. And let's call this S and R, sports and regular. And the fair had 0.54 for the sports, so about this under there. And the regular had 0.38. Get to about there. So here's sports, regular, and then the poor had 0.21, and the regular had 0.07, much smaller. The sports and regular. I mean, this graph does give us some information. I mean, you can look at this graph and you can see pretty quickly, really, that the regular class had a much higher proportion of good scores and a much lower percentage of proportion of poor scores. So it's not that bad of a graph. But if I look at the question, and this is a hard thing to understand, and make it clear to the students that this is hard to understand. It's not the easiest thing right here. Is that construct bar graphs of the distributions of performance categories for each section. So for each section, we want one bar graph for the regular section and another bar graph for the sports section. We don't really want to have all these bar graphs, one for each, good, fair, and poor. We would like one bar graph for the sports section and one bar graph for the regular section. So the answer that she's looking for is really this one right here. Let's move these out of the way. Whoa, I don't want it bigger, I just want to move them. Okay. I have the variable that I am wanting to measure and compare is the scores for the regular section and the sports section. So here, I mean, it really is showing me almost the same thing. And you might even like the other graph better. But I want to compare the two sections. Then I can see, well, the regular section, if good is the bottom part and fair is the darker red part and poor is the other part, I can see really clear that I'm going up to 100% in each section, because each section I have to account for 100% of the students. And I can see, well, the regular is a lot larger for the good is a lot better for the regular than for the sports section. And really that graph looks very similar. In fact, it looks identical. If I just looked at that piece of the graph, that looks like this piece right here, except the regular and sports are in reverse position, right? And then it's just a stacked bar chart, and if I just looked at these two pieces right here, that would look the same as the middle piece, and if I just looked at these two pieces right there, it looks at the end. So really, is this graph that much better? I don't know. But it does what she wants it to do, and it's comparing the two sections. I wouldn't stress over it, but I would kind of make it a point. I would say this is something that's secondary importance, but of some importance. Okay, so then it says comment on what these bar graphs reveal about student performance in the two sections. Well, it shows that again, I'd let them write for a minute or two and say, well, it shows that the regular section had overall better scores than the sports section. And are these findings consistent with your analysis of the quantitative variable that is the dot plot? Yeah, I think these findings are consistent with that. You know, so instead of looking at it quantitatively in terms of points, we categorized it in terms of good, fair, and poor, and we round up with the same conclusion. Not a big surprise, not a big surprise, but different ways of looking at it, categorical versus quantitatively. So, do you think it's reasonable to conclude that the sports examples cause student performance to decrease in that section? Now, here I would make a joke, because we know that, you know, if you gave a sports example, let's say Loyola, an all-boys school, they're all going to know what's going on. But not to say that girls aren't interested in sports, but I would say boys are more maniacs. They're more sports maniacs than girls as a rule. And so clearly, since it's boys that are interested in sports, they would have signed up for the sports section. And since boys are stupid, then they would have lower scores. It's totally logical. That's a joke. You don't need to make that joke, but I would. So did the sports examples cause student performance to decrease? Or put differently, or more positively, do you think it's reasonable to conclude that the regular section's assortment of examples cause student performance to improve the course? This is an interesting question, and one that deserves some discussion, because maybe in the sports section there were people that just had to take it at that time, and they were not that interested in sports. So having more types of examples would make students do better. But another factor is that the sports class was early in the morning and the regular class was later in the day. And maybe people just aren't up to their gear and they haven't got their wheels running yet early in the morning. And that's why they didn't score as well. So I don't think it's reasonable to conclude that it's the examples that changed the performance. It might have been a factor, but I don't think there's a cause and effect relationship. Okay, so that is the self-check activity. Normally I might have done that in groups, but I think we're doing it as a class. I think it's actually a good way to do it. So a couple of things to watch out for, many things to watch out for. And really this is something that you can kind of just read along and emphasize. So here, the first one, we're talking about statistical tendency. It's not a hard and fast rule. Be careful with your language on this issue. This is important. Be careful with your language. Say men tend to be taller than women. Don't say men are taller than women. So in statistics, we are not proving very many things. We are looking at tendencies. So I don't want to say men are taller than women. Men tend to be taller than women. It's an important linguistic point. Always label your axes on when you're making a graph, and we're going to make a lot of graphs, so always label your axes. Proportions are decimals between 0 and 1. You can start out with the fraction, but the fraction is not the proportion. The proportion is between 0 and 1. You can call it a percentage, but that's not a proportion. A percentage is taking a proportion and multiplying it by 100. I'm not going to get too picky about proportions versus percentages usually. So you may as well do it the right way. Bar graphs are easier to compare if you present the vertical axis as a proportion or a percentage rather than as a count. And this is a good example. So in the hand washing example that we did, if we had 100 men and 1,000 women, then the bar graph would have looked something like, and you can write this on the board. I mean, you know, if it was a count, we'd have 1,000 up here and, you know, 500 over here. And so I'm making my graph like this. And, you know, 100 about here. I mean, if I was measuring the number of women that wash their hands, I mean, that was 800 and something, 89%, you know, and the men would be, you know, like 79 of them. So that would have looked like that. I mean, yes, we know that women wash their hands more than men, but it's not that big of a relationship. The way to standardize the data is to turn the counts into a proportion, and then we get a more accurate reading. So that's an important point to make. That's why it says watch out. Be careful about drawing cause and effect conclusions. In fact, unless we're doing an experiment, and we're really not going to spend a lot of time on experiments in this class, you can never do cause and effect. You can say, well, it supports this hypothesis, but you know, I'm not proving it. And we'll have some very good examples about that. The last one I don't really understand that well, so don't worry about it. So then I have that. And then just reviewing some useful definitions. Draw a picture, draw a picture, draw a picture. The three fundamental steps in statistics. Draw a picture, draw a picture, draw a picture. Creating a graph is essential, not just for understanding the problem, but for allowing your audience to understand what you're saying. Simplest graphs to conduct are bar graphs for categorical data and dot plots. So you have bar graphs or pie charts, which I prefer actually, or dot plots. Again, label them clearly. Tendency refers to observational units in one group being more likely to be in a certain category. I don't know. Tendency refers to center. Center / on average. That's what we want. When you see the word tendency, that's what we're looking for. And consistency refers to how variable or spread out the data is. Yeah, and so it says, always talk about center and spread. Okay, so I think that, yeah, I can stop here because this is just a table for something else. So that is the self-check that you'll be doing in class. I hope I'm not overwhelming you, but I'm sure you can do it well. We'll talk about it in person. All right. So let's move this out of the way. Let's